Hello, welcome back. In this video, we'll be looking at for loops, right? So as the name suggests, loops are basically a repetition in program, which allow you to execute a series of statements more than once. This allows you to perform the same operations onto multiple values, which is quite useful in practice. There are two ways of achieving this. One is the definite loop, which we call the for loop. This is used when you know exactly how many times you want to execute the loop for. And then there's the indefinite conditional loop, which is the while loop, where you define the condition to run the loop as long as the condition is satisfied. So in this video, we'll focus on the for loop. Later on, you look at the while loop after covering the conditions. Okay. So the syntax for loop is quite straightforward. We write for variable in some iterable list. You do the block, the code inside the block. Okay, and the code inside the block is performed sequentially for each variable inside a list value. So the variable is going to be holding the value inside the list one by one, and then you perform the given code inside the block to the value variable. You don't actually have to use the variable, but often that's what we write the loop for. Because if you don't need to use the variables, then there are only a few occasions where that will be helpful. Okay. So we will call these a for loop or a for each loop. Okay, here's an example where we have a list running from 0 to 6, and we have a variable I. Okay, and we're going to calculate the square root of the value I and just print it. Okay. So let's run that. So I have that code here. And then execute it. So you can see that 0 squared is 0, 1 squared is 1, and all the way to 6. Okay, so that's a very simple code, but you can see that just a few lines of code, we are able to achieve the output where it shows you and calculates the squared value of a given variable I. Okay, so if you do need to do some repetitive task for a large number of variables, then you can see quickly that for loops are very useful. Okay, so here is a flowchart view of what the for loop is doing. So that's an example for num in 10, 20, 50, and minus 30. We're just going to print a number. Okay, so the very first thing it's going to ask is, do we have any more elements in as a variable that we need to do? Well, obviously, at the very first time the for loop runs, the first value, so for this instance, the value 10 is assigned to num. So behind the scene, it's doing num equals 10. Okay, and after that, you jump inside the block, which in this case, we are doing print num, and num has the value 10. So it's going to print 10. Once the block has finished, what it does is come back to the for loop definition. We have finished using the value 10. So that's where the bookmark for our list is. The bookmark gets moved to the next item, 20. So now there's a behind the scene num equals 20, and then you execute the block. So you do this until the last item. So say num was -30 now, and then we finish the block, it will come back to the for loop, and the bookmark was at -30, and then it will go outside and is pointing at nothing. So at this point, when that happens, it finishes the for loop. So in that case, that's where you satisfy the condition, done all elements, you say yes, and then go to the next part of the code that's not inside the for loop. So if you have more code after the for loop, so that's the ones that are not indented inside the for loop, you continue on from there. Okay, and there are different ways of using the for loop, and most of them will be describable through these 4 patterns. So let's have a look at these 4 patterns and how they're useful in different applications. Okay, so the accumulator pattern is the one that accumulates the value and stores that value for later use. So for example, find the sum of elements of an int list. So there is a list given that contains the integer values, and you just want to find the sum of it. So without using the built-in function sum, of course, because this is to exercise your understanding of the for loops, but you can imagine how the built-in sum function is written. So it's written in this way as well. So how would I do this if someone read out a list of numbers to me? Well, basically, you're going to have a variable, and as somebody keeps on reading the values to you, you're just going to keep on adding it to what you have. So that's what we're going to do in our for loop. So we have the total variable defined before the for loop, and inside the for loop, as you go through the data, we are adding the values. Okay, so in general form, we can write the accumulator pattern as follows. So we have some accumulator variable. We will initialize it to some value. So if you're doing the additions, it's going to be initialized to 0. But in some scenarios, say you work in a finance sector, you may have some carryover balance, then that may be your variable that starts as the initial value and so forth. So depending on the scenario. And then you use the for loop to go through the list of elements, and then you update your accumulator variable based on what you find in your element. Okay, update may be simple addition, but it can be as complex as conditional on the value of the element. So for example, if you want to ignore all the negative values, then you might have a condition to check that before you add it. So find the sum of the positive elements here. Involving multiple accumulators, you might have more than one variable that's accumulating different types. So for example, iterating to find both the maximum and minimum values. Again, the built-in functions exist for max and min, but you can imagine that they would have been written using a for loop like this. So here are some more accumulator examples. I won't be going over them, but you can write them yourself and see whether they perform as you have intended. Okay, so the next one is the mapped list pattern. Sometimes given a list, we need a new list in which each element is derived from the corresponding element in the first list. Okay, so that means we are mapping it from the original value to a new one. Okay, for example, given a list of numbers, compute a list of numbers squared. So like we have seen before, we just printed it, but this time we want to keep a record of the squared values because we want to use it for something else. Another example, given a list of strings, compute a new list of strings in uppercase. So definitely we want to have 2 separate lists containing the final values that are of uppercase strings. Okay, so this can be done with a variant of the accumulator pattern, but instead of having a single variable, we have a variable that is a list. Okay, so here's an example, which I have here somewhere, def square. There we go. So we'll quickly observe the code first. Okay, so we have an initial list as a result. And for num in nums, result.append num times num. And then finally, we will return the result. Okay, so when we say return result, we are returning the list, but this list has been populated using the for loop. Okay, so numbers is the original list, and squares is the returned list by calling the squares function. Okay, because these are simple function calls, we don't really need to use f strings, but we can do that. Okay, for consistency. Like this. Okay, so this has the same effect here as well. So if I just do that, and needs to be an f string. Okay, a little bit wider. Here we go. Okay, so if I execute this one, inside numbers, this is the original list, is the as same as what we have defined. In the squared is 1 squared, 9 is -3 squared, 121 is 11 squared, 10,000 is 100 squared, right? So we have created two different lists. Oh no, we have created a new list by doing some calculations on the values inside our original list. So this is the mapped list example, which follows very closely with the accumulator pattern. However, this time we're not keeping single value, but multiple values. And the next one is the counting loop pattern. As our very first for loop, we printed a table of squares, right? So that's the exact same code as before. This is a simple counting loop, basically. But what if we wanted to do this from 1 to 1000? Obviously, we're not going to write 1 to 1000 in a list. Instead, we can use a range function to provide a counting loop for us. So here's a converted version for I in range 0 and 7. So similar to the list and string slicing, you find that the first value given is our starting value, and the second value given is our finishing value, but not including. Okay, so let's test that out. Our next example is here. Okay, so for I in range 0 to 7, we should print the squared value. Okay, so this one, 0 squared is 0, 6 squared is 36, is what we had before, and we can quickly change this. Say, I want to up to 20, okay, and execute that. Then obviously this is going to give us all the way to 20, but of course not including 20. So if you want to print out 20 squared as well, you would have gone to 21. And this works in an integer values. So increment is by 1. If you want to change the increment, you can add a third variable, say increment of 2. So I want to increment from 0 by going up by 2. So I want to only see the even number values. Then we can add 2 there and execute. Okay, so now we see that 0, 2, 4, 6, 8, all the way to 18. But the next up is 20, but this is not including 20, so it stops at 18. Of course, if you want to display by the odd numbers, you can change where you start. Start from 1 and go by up 2s. Okay, so we can execute this. Now we have all the odd numbers squared here. So that's how the range can be used. So if you can also define only a single value, 10, then that means by default, we are starting to count from 0 up to 10, but not including 10. So if we do this, we will expect the output to include 0 all the way up to 9. Oops. All the way up to 9. Okay, 0 to 9. So what the range function actually returns in the shell, let's type that in. Do I have a Python shell? Let's create a Python shell. Range 0, 7. It just says this range 0, 7. So let's try to see the type. Type range 0, 7. Okay, and it says it's a class range. Okay, So range is not actually a list, right? So as you can see, if I go type list, that's a type list, class list, whereas range is actually different. Okay, so you might have expected that it might create a list, but it's actually range has its own type. Okay, so it's not a list, it is just happen to be a special class of objects that when you iterate over it, it gives you the numbers 0 through 6. You can easily convert it by casting it, list range 0 to 7. Okay, so if you do need some like counting numbers as a list, you can just use the range function, which returns a type range, but you then cast it onto the list, which will convert it for you as a list. So list and range are both examples of more simple Python type called a sequence. Sequence can be indexed, which means you can provide its position value to access the data inside at that position and iterate it over with a for loop. Okay, and interestingly, strings are also sequences. If you didn't expect that, because it's made up of series of characters. So you can try this code yourself. Just like the list slicing, you can slice the strings as well because they are part of the sequence in Python. So char in name, you can print char. This will print out each character in the name, one per line. But unlike lists, strings and range objects are immutable. So remembering from the tuples lecture video, immutable means you cannot change the values assigned to them if they have already been defined. Okay. So let's give you an example. A equals 1, 2, 3, and S equals 1, 2, 3. So they both contain 1. So A of 0 is 1. S of 0 is also 1. Okay, but I can say that A of 0 is now 6. And if I look at A, so now it's 6, 2, 3. But I cannot say S of 0 is now 6. It's going to complain because it's immutable. So this means I cannot change the element inside once it's already defined. You will have to redefine the whole thing with the new values. Okay. So this is important because now we are looking at the updated list pattern. So we can do this with lists because lists are mutable, which means we can update the values, whereas we cannot apply this pattern onto strings or range, which are immutable. So as an alternative to the mapped list pattern, where you end up with a new list that contains the values that you have newly calculated, we can instead modify the original list. By doing this, the function will then usually return none because it doesn't have to return anything because your original list is already accessible from outside the loop or the function that you call it with. Okay, so write a function that scales up all the numbers in a list by a given factor. Let's have a look at that. So here's the code. We can look at inside the editor with its pretty colorings. There we go, scale up. Oh, doesn't. Oh. A little bit bigger. There we go. Okay. So scale up is a function that takes in two variables. Nums is a list, and scale factor is the scale that I want to apply to each element in nums list. Okay, so for num in nums, we say num equals none times scale factor. And then we're going to provide marks and then scale. We will check whether the list has been updated before and after. Okay, so let's run this. Save and run. Here, so mark is 55.3 and blah, 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 but the scaled mark is also the same. even though we wanted to scale up by a factor of 1.2, right? It didn't work. So what's going on? Well, you have to think from how the values are stored inside our memory space and think about what's happening here. So the assignment num equals num times scale factor binds the num to a new object. So num is actually a variable created to run the for loop. So actually, it gets added into the dictionary of the variable names. Okay, so when that happens, the num is assigned with the value and you want to do something with it. So if you update the variable num, it used to calculate 55.3 as the first object. When you say num equals something else inside the block in the for loop, what it is doing is actually updating what this particular variable num is pointing to. So it originally pointed to 55, but after the calculation is now pointing at 60. Okay, but what's more important here is what the list is pointing to. What is contained inside the list? So list contains these references, which points to these values. Okay, and what we really want is this reference to point to the new value, but obviously that did not happen inside the for loop block. Hence, when we finish the function of scaling and then trying to print out the original nums list, nothing has changed inside the nums list. And this is a typical aliasing problem. Okay, so what do we really want from this scenario? Well, what we really want is we still have this nums variable pointing to the list, but the list object is referencing a new value after the scaling. Okay, to achieve this, we use a mixture of met list pattern and a counting loop pattern. So let's have a look how that's done. So here's an example, which I have also available inside my IDE. So let's have a look at that in IDE. Okay, so the same thing, but if you look at this, oops, the code has changed a little bit. Before we had a for loop saying for num in nums, right? But this time we're using the range function. Okay, so what does this range do? It's the input to range is len of num. So len function returns the number of items inside the list. Okay, and range function, if you give a single number, it starts from 0 up to that number without including. So if I have 3 items inside my list and len of that particular list will be 3, and range of 3 will be 0, 1, 2, because it does not include the number that's given. And these numbers will be the index of the items inside the given list. So I can access each value using the index, which in this instance is variable I. So when I say for I in range len nums, what it's returning is index of every item starting from the first one. Okay. Now, using that information, we can say that nums I, the nums, we need to use the whole list because we're updating that. Nums I equals nums I times scale factor. Okay, so this time I'm actually referencing the value from the list rather than creating another variable and changing that. So let's run this, save and run. You can see that the marks have updated as expected. This is supposed to be 66. Okay. So you can see that now it is updating correctly, which is good because we have just achieved this. By referencing nums I, we are looking at updating this reference to the new value. So this should be 66. Oh, yep. So now it's working correctly. Okay. So for the style rules, prefer met list over updated list unless there is a clear performance improvement. So for example, you can do this instead. Okay, so by creating a new list and providing, because sometimes if you modify a list that's coming outside of the function, you might use the original value somewhere else, so it can be quite confusing. That's why this mapped list is more preferred than the update list, unless the performance is a significant downfall. Okay. Another option in this area is to use the enumerate function. The enumerate function takes a sequence as a parameter and returns a new sequence, which is an enumerate object in the format of index value pairs. So this is actually very useful because original list is now returned in another list, but now in the form of tuples that contains the index value and its original value. Okay, so now the scalar function can be rewritten as follows. Okay, comment that out. Here is the rewritten scale function. Sorry, this is the accumulator mapped function. So here's the index one, enumerate one. So for I, comma num in enumerate nums, nums I equals num times scale vector. Okay, so you can be the judge of which one reads easier than the others, than the other. So either this one or the range one. But I think that many will find this particular format easier to read compared to the other one, where you have to reference nums I in both sides of the equation, whereas here you're referencing nums I only on the left-hand side, and on the right-hand side you are referencing the num, which you get from the nums list. Okay, but it can be up to the style guide which one you would like to use. Okay, so next one is the list comprehensions. So if you are doing computer science as a core, this is a very good thing to learn. You will not be examined, but it will help you better to write more efficient Python code later on. So even if you're not a CS major, this will still make your code much more neat and nice. And many Python programmers will prefer writing the list comprehensions than writing a for loop to do this. Because once you get used to this, it's quite easy to understand what it's trying to do. So syntax is quite simple. Expression 1 for variable in sequence if expression 2. Okay, so this is to quickly go over a original given sequence. This one, sequence is some sort of input. It can be a list, it can be a string, or it can be a range, or whatever you want. And this variable is the one that is iterating over it. Okay, and then expression 1 is your block from the for loop. And you can also add a condition 2 as well. Okay, so this yields a list of the values of expression 1 for each value of the variable in the sequence, including only the cases in which expression 2 is true. Okay, but do note that the if expression 2 is optional, so you can have the simple syntax of expression 1 for variable in sequence only. So let's have a look at an example. We'll need a Python shell here. Nums equals, I'm just gonna, there we go. The same, 0 to 5. And then we want to create a squared list, right? So before we wrote a for loop for I in nums, squared I equals I times I, right? So we can write something like this, but this time we can use I as well. I times I for I in nums. Okay, so you can see that the new list that it produced contains the squared value of the original list nums. Okay, and also if you have like a word variable, word equals, this is a long word. Okay, so we want to find the length of each word inside the given string, assuming that each word is defined by a sequence of characters separated by a space. So we can create things like len word. That's what we're calculating for len, let's just w, for w in word dot split. Square bracket, right? So you can quickly find that the length of each word is 42144, which is true from the given string. So I actually should have named it sentence. It's actually not a word. Nevertheless, that's what we get. If you do have some files, we can do stuff with the files as well, and so forth, right? And the last one, let's quickly do the last one. X times x for x in nums if x modulo 2 equal 1. So what does this mean? Remember that this particular operator is looking for a remainder, right? So if x was 3, 3 modulo 2 is 1. 4 modulo 2 is 0, 5 modulo 2 is 1, and so forth. So this condition is actually finding whether the number is odd or not. And this is true if the value is odd. So out of all the numbers inside nums, I'm only going to square values if the value is odd. That's what it's saying. So if I press enter, you'll see that you get a 1 squared, 3 squared, 5 squared, but no longer the 2 or the 4 squared. Okay, so this is how we can write list comprehensions in Python. But don't worry, it's not going to be examined in this unit particularly, but it will be a very useful thing to know if you are going to continue programming using Python. So thanks for watching. That's it for the for loops. Yeah, I'll see you in the next video. Bye.